ways that we can graph a line. 2 points, we can connect them together. Okay, that's the most basic. If you have a point and a slope, you can graph a line. Now, if you have an equation, you can also graph the line, because what you'll do is you'll solve it for y. That's going to get it in slope-intercept form, and then you can get your slope from that and your y-intercept. So right now, it's currently in standard form, which remember, when you work out questions out of 2-3, your answer has to be in either standard or slope-intercept. So we need to get it in slope-intercept form so we can get our slope. So we're going to begin by moving that 3x over. And then we've got minus 5y equals minus 3x plus 4. And then we'll divide by a negative 5. And then we'll rewrite this as y equals now negative and negative makes it a positive 3/5 x and a minus 4/5 there. Is everyone all right with that? So, generally speaking, in this chapter, if you're in doubt as to what to do, solve it for y. Because that's generally, if you have an equation, going to get you started in the right direction. So now we need a point and a slope, and the slope is going to be the number in front of the x, so that's your 3/5, and the point is going to be your y-intercept. And that y-intercept as an ordered pair is 0, negative 4/5. Now we can graph it. Now what about negative 4/5? Well, it's a fraction, but what's negative 4/5 as a decimal? Well, that's negative 0.8, right? So where would that be at? That would be in between 0 and negative 1, and it's going to be closer to negative 1, isn't it? It's almost negative 1. So let's begin by plotting our point, our y-intercept here, and we're going to be at 0 and about down 1 unit. So right about there. Close to that. What about my slope? Well, my slope is 3/5, and it is rise over run, so we go up 3, and then we go over 5 units. So 1, 2, 3. So we went up 3, and then over 1, 2, 3, 4, 5 units over. So up 3 and over about 5. We make our new dot, and then we connect them together, and that then forms our line equation, or our graph here, from the line equation. So that's how you graph a line equation. Solve it for y, get your slope, and that b, the number on the end, that is your y-intercept. If it's a fraction, you just kind of figure out about where it's at. These do not have to be perfect graphs. We're not using a computer. We're just sketching these by hand, so we just kind of get an idea. And in your homework, you have graph paper, so that makes it easier for you. Now, 11 is very, very similar. So let's make sure we know how to do 11 as well. And same procedure, move that 3x over. And then we've got minus 4y equals a minus 3x minus 24. We'll divide by our negative 4 everywhere. And then we want to reduce it down as much as possible. So negative and negative makes it a positive 3/4 x. Negative and negative here makes it a 24 divided by 4. Well, that's going to be a positive 6, isn't it? Okay, so we have everything we need to graph this, and we need to find our slope. That's the number in front of your x, so that is 3/4. And then our y-intercept. Well, what would our y-intercept be? As an ordered pair, that would be 0, 6, wouldn't it? Now, do we have everything that we need? Yes, because we have a point and we have a slope, so we can easily graph this equation. And so where are we going to start at? We're going to start up 6 units. And that's going to be right about there, 6 units up. And then our slope is 3/4. So that means we go up 3 and we go over 4. So 1, 2, 3, up 3, and then over 1, 2, 3, 4. Over 3, over 4. Make our new dot, and then simply connect them together. So I wonder how I did those now. Does that make sense? Okay. I know we didn't really have any questions out of 2, 3, but I'm going to do 2 of these just to remind us on how these work. And 2, 3, I think, is a section that is definitely going to take you the longest to go through. Do we have any others out of 2, 3 to look at besides 8 and 9? Okay, we'll do those 2. And then the next section is quite a bit easier. The next section, I think when you work through it, it's much easier than 2, 3. 2, 3 is definitely the hardest. So just to kind of give us a review, all work out 8 and 9. And so for question 8, we've got a point, and we have a line equation, and we want it to be perpendicular to minus 3x plus 4y equals negative 23. So we'll go to our flow chart. Now, does everyone have that flow chart? Amber, did you have that one? Okay. Yep. I've got an extra one here. Okay. Yep, you're welcome. So we're going to use that flow chart, and we're going to go to that 3rd page. And on that 3rd page, we start following the directions here. And how do we know we're on the 3rd page? Okay, well, what do we have? So first thing we need to identify is what we have. So we have a point and we have a line equation. Now the first page is when you have a point and a slope. We don't have that. The second page is 2 points. We don't have that. But the 3rd page, right, we read the directions here and it says, find the equation of a line given a point and a line equation. Easiest possible way to do these is to use the flow chart. Follow it just like a recipe. So this is what we've got. We follow it down. So what does it say to do? It says you need to solve that equation for y. And then we'll find our slope. So let's do that. So that's where we'll begin, is we'll solve this for y. Minus 3x plus 4y equals a minus 23. So we'll add that 3x over. And then we've got 4y equals now 3x minus 23. And then we'll divide by our 4. Rewriting, that leaves me then with y equals now 3/4 x minus 23. Now, all we need is the slope. I don't care about the y-intercept. All I need is the slope. So the slope from here is 3/4, right? Now, we may or may not use that slope. So which one are we going to go down? We have 2 sides here. Okay, the parallel side over here, we use this one. That would be using the same slope. But we don't have that, do we? We want the perpendicular side. So what does it say for the perpendicular side? It says use the negative or the opposite, so opposite signs, reciprocal slope. So we want the parallel, or not parallel, perpendicular. So we're going to use m equals, we flip it over, 4/3, and then we change our sign. So That is what we're going to be using. Okay, we're going to use minus 4/3 because we have to flip it over and then we change the sign. Now, once we've done that, then what does it point back to? Okay, then it points back to point slope. So let's go ahead now and apply our point slope formula. And I always like to write the formula out. That way we have it. And for our point slope formula, we're going to be using minus 3, 8 for our point. And our slope is minus 4/3. This is x1 and this is y1. So is everyone okay with how I got to this step? And these, I think, are the most complicated because it is nothing but algebra. Now, we apply our point slope formula, and the point slope formula is, or point slope formula is y minus y1 equals m times x minus x1. So we're going to be plugging in our x1, our y1, and our new slope. So let's go ahead and do that. And that's y minus 8 equals minus 4/3 times x. Now, be very careful about the double negatives because in some cases you have one. Minus that minus 3. And we also need to make sure we know how to write the answer. And on 8, it says write it in slope-intercept form. So we're going to clean this up a bit. We'll clear out the fractions if we need to. And then we'll solve it for y. So double negative here. It's going to make that positive. So when we distribute through, we have y minus 8 equals minus 4/3 x. So there's that piece. Double negative makes that positive, times a negative keeps it negative. And how do we handle this when we multiply? We put that minus, or that 3 over 1 here. 3 times 4 is a 12. 3 times 1 is a 3. Now, always try to reduce down because you may not have to clear the fractions. Well, minus 12 over 3, that reduces down to a minus 4, doesn't it? Now, we don't have to worry about getting rid of the fractions because what do we want? We want this in slope-intercept form. And what does slope-intercept form look like from our chart? Well, slope-intercept form is here, and slope-intercept form is y equals mx plus b. So we don't have to clear that fraction out because all we need to do is what? Add the 8 over, and then we've got it. So this is in slope-intercept form here, and minus 4 plus 8 makes it a positive 4. That is the answer for that. And I know in 2, 3, they're a little bit tricky because it's all calculation. You've got to be very careful and make sure that you don't make a sign error. That's where students usually make mistakes. It's not so much the process, it's sign errors. Now, I picked question 9 because question 9, we have 2 points. So it is a little bit different. And how do we handle the line equation when we have 2 points? Well, we go back to our second page. And the second page here, what does it say? I think the flow chart is going to make it so much easier. All you do is just follow the directions. So the second page says, find the equation of a line when you're given 2 points. So that's what we have. Okay, so we've got 2 points. And then what do? First thing, find the slope. So let's do that. And our formula for the slope is m equals y1 minus y2 over x1 minus your x2. Now, when we use this formula, where students make a mistake at is they mix up the x and the y's. I see it happen all the time. X is first, but it's not on the top of the fraction. It's down below. So make sure you put these in the right place. So we need y1. What's y1? -4. Not the 3, right? We need the y component. Minus y2, which is that 3, over 3 minus 0. And then we put them together, and that's going to make it then -7/3. Is everyone okay with how I did that? Now that's our slope, right? Okay, so follow it just like a recipe. We found the slope. Now what? Now once we found the slope, okay, then we go where? Point slope formula. And this is what we're going to be using for our slope. So now we're going to use point slope. Slope form here. And for the point slope formula, you have y minus y1 equals m times x minus x1. And it doesn't matter which ordered pair we use. We'll just use the first one. We're going to use our slope, which is -7/3. And then we'll use that ordered pair, 3, -4. And that's x1 and y. Let's just take a little bit of time to go through. And now we'll just fill it in pretty quickly here. Shouldn't take long. Watch out again for double negatives. So we've got y minus a -4 equals -7/3 times x minus 3. And what are we now going to do? Double negative here makes it what? Positive. Distribute through over here. So now that leaves me with y plus 4 equals, distributing through, -7/3 x. Double negative makes it positive. And -7 times a -3, that makes it a positive 21/3. And what do we know about 21/3? Well, that reduces down to what? 21/3 reduces down to 7. Now, how do we want to write our answer? Because we have to be careful. All right, we want to write our answer in what? We want our answer in this case it says, standard form. So, can we have fractions at all in standard form? No. So let's go ahead and multiply all of this by 3 to clear out our fractions here. And then we'll just simply move the x over, and then we'll be done. So distributing through, we get 3y. 3 times 4 makes it 12 equals, 3's cancel, -7x there, and 3 times 7 makes it a 21. We'll add our 7x over, and then we'll also subtract off the 12. So let's rewrite it, and this will be our final answer. So my final answer would be 7x plus 3y. We move it over, move the 12 over, and 21 minus 12, well, positive 21 minus 12 should make it a positive what? Positive 9 here. Is everyone all right with that so far? Okay. Does anyone need the homework packet from? Yep, I've got that for you. Last time we just went through 2, 3. Okay, so you can go back and you can review the notes and watch the videos if you need to. Now we're going to go ahead and start the new lecture, and we're going to be looking at 2.4. 2.4, quite a bit easier. It's actually, I think, not bad to do, it's just shading. When we go to graph these, we're going to be shading because these are going to be inequalities. And when we go to shade them, we're going to shade the true half. And then instead of having brackets and parentheses, we're going to be having a dotted or a solid line. This section, I think, is actually pretty easy for most students. When we go to graph these, if we have a strictly less than or strictly greater than, they're going to have a dotted line, and a greater than or equal to, less than or equal to, well, those are going to have a solid line. These, again, won't take long at all to go through. We're just going to have to solve and graph these. Or just graph because we're not really solving anything, but we're just going to graph these. And we'll start off with an easier one. How about y is less than or equal to 3/5 x plus 5. Okay, now what we do is we graph it just like it was an equals. But then we're going to have to shade because there is an extra step here. Now, if I want to graph this like it was an equal sign, I need my slope, which it's already been solved for y. So my slope is 3/5. And this 5, well, that's your y-intercept. And so that's your point 0.05. So the only difference, the only new part, is the fact that we're going to be shading and graphing here. In this case, I said it was less than or equal to, so it's going to get a solid line. And we're going to start up 5 units. 2, 3, 4, 5. Okay, so we're going to start here at 0.5. And then what's my slope? My slope is 3/5. So we go up 3, and we go over 5. So up 1, 2, 3 units. And then over 1, 2, 3, 4, 5. So 5 units over. That makes my new dot right there. Now, why are we going to use a solid line? Because it is less than or equal to, or greater than or equal to. Those have solid lines. The less than and the greater than, well, those get the dotted. So this gets a solid line here. Larger here. Now we need to check, and we check the 0, 0. And we're going to shade where it's true. So all you need to now do is check 0, 0. 0, 0 is right here. So let's find it. That's where it is. And we're going to check it in the original. All right, so we just check 0, 0, and we see if it's true or false in the original. And 0, 0 is what you always want to check. Unless it goes through it, then you pick a different point. But 0, 0 is usually the easiest one to pick. And now we see if it's true or false. Well, 3/5 times 0 is 0. And is 0 smaller than 5? Is 0 smaller than 5? Yes, right? Because it's opening towards a larger number. So that would be then what? True. So that makes this half true. Now the line is going to separate. So this line separates the true from the false. So in this case, we found 0, 0 to be true. So that means the lower half is true. So the upper half is false. Now, where we shade is we shade the true regions. And so where is it true? Well, it is true down below. So we shade below the line because that half was true. So they're not bad at all to really work out and do. Let's try another one. About 3x plus 6y equals 12. And let's not use equals, let's do, how about greater than? So we'll just do strictly greater than 12. So that's what I want you to work with. And we're going to graph this one out here. Now, first off, this one has not been solved for y. So we need to make sure that we solve it for y so that we can get our point, the y-intercept, and our slope. So I put a box around it so we don't lose the original, because we're going to have to check this in the original. But let's go ahead and move that 3 over, the 3x over. And we can just replace that with an equals. If you want to just leave it with the inequality. We'll just replace it with an equal sign because we're just going to graph it here. And then we'll divide that all by 6 here. And then we reduce. So reducing it down, y equals now minus 1/2 x. And 12 over 6. 12 over 6 leaves it with a 2. And what is my slope? Well, my slope would be a negative 1/2. And what is my y-intercept? Comes from here, and it's 0, 2. So we're going to start up 2 units. And we need to make sure we know if we use a dotted or a solid line. So which one are we going to use here? This one says it is strictly greater than. All right, so strictly greater than or strictly less than, they get a dotted line. What is our slope? Our slope is minus 1/2, so we're going to go down 1 and over 5. So down 1, and then over 1, or sorry, no, down 5, down 1 and over 2, sorry about that. So we're going to go down 1, okay, and then over 2. Here's my second point. Now we are going to connect them together with a dotted line now. Okay, so that's the only major difference is that. And then we check 0, 0. Where's 0, 0 at? All right, 0, 0 is right here. And so now we're just going to check our 0, 0. And what does that give you when you plug in 0, 0? Plug it back in our original here, and that's going to give you 3 times 0 plus 6 times 0, and we see if that's true or false. So is 0 bigger than 12? Is that true or is that false now? Which one would that be? Is 0 bigger than 12? It's not, is it? So that would make that then what? False. 0, 0 is here. So the lower half is false, the upper half is true, and where do we shade? We shade the true part, so we're going to be shading on top, and we're going to be shading up here. Let's do another one. Let's do an easier one. How about we do a vertical line? We'll do 2 more, and then we'll move on to the next section. Because it's a short section as well. So let's do one more of these. Let's do a vertical line. How about we graph x is less than or equal to negative 4? This one's actually pretty easy if we remember what an x line looks like. So when we talk about these lines, remember there's 4 different outcomes. It can be a diagonal line that goes up from left to right, a diagonal line that goes down. You can have a vertical line or you can have a horizontal line. Now, what about x equals that negative 4? What would that look like? Well, it crosses the x-axis. And here's your x-axis. So that's back 1, 2, 3, 4. All right. And that means it's going to be a vertical line. And because of this right here, it's going to be a solid line. So that's going to be a solid vertical line, just like this. And where do we start at? Well, we check that 0, 0, and we find that 0, 0, which is right here. We're going to check that 0, 0 out. Now, the only part we need to check is the x part. All right, so we're going to plug in 0 for the x part. That's our x and that's our y. And then we see if this is true or false. And is 0 smaller than a negative 4? Is 0 smaller than a negative 4? No, right? That would be, in this case again, what? That would be false, right? Because 0 is not smaller than a negative 4. So that means this half is false. The vertical line here separates the two. So the other half is what? True. And where do we shade? On the true side. And that's what we have. Okay. Let's do one more. And this one's going to go through 0, 0. So we're going to have to pick a different point. So we want to go ahead and graph this one. Now, again, what do we need to do? We need to make sure that we have solved this for y. So I'm going to move that 5 over. Now, this is what we're going to start with. So I'll put a box around it so we don't lose it, because we have to check it in here. And we're going to move that 5x over. And then we can make it equal. So y equals a minus 5x. Now, if I was going to go to graph this, there's no number on the end, so that's like having a plus 0. So that would make that then 0, 0 for the starting point. Our slope is a negative 5, so m equals negative 5 over 1. And we're going to start at 0, 0. And we've got a negative 5 over 1, so we go down 5 and over 1. Down 5 units here, and then we're going to go over 1, make our new dot. And can someone tell me, dotted or solid line, which one? Which one's it going to have, dotted or solid line? We look at our inequality symbol here. Do we have a bar underneath it? No. So that means this is going to get a what? Dotted line, right? Because if it's greater than or equal to, remember here's our rule, greater than or equal to, less than or equal to, solid. Strictly less than, strictly greater than, dotted line. So ours is going to get a dotted line. Now, we cannot check 0, 0. Why not? Because our line goes through 0, 0. So let's pick a point that is not on the line. Any point that you want to pick is fine. I'll just start right here with this point. And I'm going to pick a point that is not on the blue line. So how about we pick 1, 0? Okay, that is right there. We know where it's at and we can check it. So because it goes through 0, 0, we're going to have to check a different point. And we're going to check 1, 0. And where do we check it back into? The original clear up here. So we plug our values in. And remember, this is your x, this is your y. We'll plug our values in. So that's going to be 0 plus 5 times 1 for the x is less than 0. Well, that gives you 5 is less than 0. And is 5 smaller than 0? No, it is not. So that would make that then false. All right. And 1, 0 is right here. So that means this half is false. This half then must be what? True. The blue line separates the two. Where do we shade? We shade the true half. Now I do want to work out one of the homework questions, because there's a couple of these where they give you the graph already, and all they want you to do is shade it. So we're going to look at question 2 from your homework, and this is out of 2.4, and we're going to look at question 2. Now, don't try to make this one harder than what it needs to be. There are 3 or 4 of these where you already have the graph. All right, they gave you the line there. All you need to do is shade. You'll either shade above the line or you'll shade below the line. So how do we know where to shade? Well, what do we pick? 0, 0. Does this line, does it go through the 0, 0? No. So there's several of these. So we're going to start right here at 0, 0. So let's check now 0, 0. And we're going to check it in the original. So we're going to plug this 0 in because you already have the line. So these are actually easier. On the left-hand side, all comes out to be 0. And then is 0 bigger than negative 10? Yes, it would be, wouldn't it? Right? 0 is definitely bigger than negative 10. So that would make that then true. So that means this half is true. The lower half is false. And where do we shade? The true half, which is going to be where? The upper part. So that's all I want on question 2. Same thing with question 3. Check your 0, 0 and either shade above or shade below. That's all you need to do. On some of the others, you're going to have to graph the lines like what we did. But there are several of these where you already have the line, and all you have to do is pick 0, 0 and either shade above or below. So about half of them are like this. The other half, you're going to have to do the whole part like this one. Okay? This is a Y line. You're going to have to graph it and shade it. But several of them are already done for you. Now we do have a little bit of time left. So we're going to start the next section, and we may or may not get through all of 2.5. We're going to see how far we get. We'll get through most of it, I think, at least half of it. So we just did this one, so you can refer back to the sheet, see how we did 2. Okay, but let's now move on, and let's look at 2.5. And 2.5, we're going to talk about functions. And then we're also going to talk about the domain and the range. When we go to graph things, we have what are called functions and things that are not functions. And how to tell if something's a function is we use what's called the vertical line test. And it's very easy. For the vertical line test, all you have to do is you draw vertical lines. If any line touches the graph, at more than one place, it is not a function. So we'll give you a moment to write up this definition. So all we're going to be doing is, it's very easy. We're going to be looking at pictures, all right, and we're going to be drawing vertical lines. And if any vertical line that we draw touches the graph at more than one place, it's not a function. And we're also going to be talking about the domain and the range. And this is also an easy concept. The domain is the values of x. So the domain goes with the x values. And your range Well, that goes with the values of y. So we're going to be looking at some pictures, and this is not calculational. And we are not doing any calculations at all. This is nothing but looking at pictures. So I'm going to give you some pictures, and we are going to identify if it's, or determine if it's a function or not. Okay, so that'll be a yes or no question. And then we're also going to get the domain and the range. And so it's very easy. I think it's one of the easiest concepts once you see how it all goes together. So domain is values of x, range is values of y, and we're going to be looking at graphs. So we'll start off with a parabola, a U-shaped curve, and we'll have this one going down. So here's our graph. Now, I want you to tell me if this graph is a function, yes or no, and also find the domain and the range. So, how do we determine if something's a function? Well, to determine if it's a function, we draw vertical lines. So we're going to draw vertical lines through the graph here. Now look at each line. How many points does each line touch? Okay, each line only touches that graph at what? One place each, right? This one touches at one place, this one's one place, this one's one place, that one's one place. If it touches at only one place, then it is a function. If it touches more than one, it's not. So this would be a function. And what about the domain and the range? And the domain is the values of x. So we'll start with the domain. This is positive x and this is negative x. So what happens with my graph here? Okay, if I'm here, what happens is I follow the graph. It goes down and it does what? Spreads further out, doesn't it? Okay, so we're only looking at the left and the right part. So as it goes down, what's it doing? Getting wider, so it's going to negative infinity, and it's also going to positive infinity, right? This way is negative infinity, this way is positive infinity. So my graph is going to the left and to the right, so my domain would be negative to positive infinity. Now, what about the range? Okay, range is the y part. Now look at your graph here. It's a U. Does it go up here at all? No. Okay, where does it start at? On the y-axis, because we're looking at the y-axis here. Where does it start at? It starts at 4. Okay, and where is it going? Down. And if it goes down, where does it go down to? Negative infinity. So your range, okay, we'll put the negative there, would be, and make sure you put it in the right order, our range would be negative infinity to 4. Now you always make sure the smaller number is first. Negative infinity is smaller. And so where does it stop? At 4. So it goes down. So my range would be negative infinity to 4. Let's look at another one. Once you do a few of these, it'll make sense. And they're not difficult at all. They're actually very easy. Is this going to be a function? Yes or no? Let's draw vertical lines again. Each line touches the blue graph at what? Only one point. If it touches at only one point, then yes, it is a function. What about the domain? Now we have to be careful with the domain. A little bit different from the last one. The domain. Domain is the values of x. Remember, this is your negative x, and this is positive x here. Now, does it go back in this direction at all? No. Where does it start at on the x-axis? Yeah, negative 3, right? Got it labeled here, negative 3. And where does it go to? Yep, positive infinity, right? What about the range? Let's talk about that one. The range is the up and down part. So this is the y-axis here. The y-axis is up and down. And so here it is. Does it go down at all? No. Where is it at on the y-axis? Remember, it's going to be here at what? 0, and what's it doing? Going up. So my range would then be 0 to what? Positive infinity, because that's 0 on the y-axis. You're looking at the y here, and it's going up. And that one was a function. What about a diagonal line like this one? What would this one be? Function or not a function? Can someone tell me? Do you think it's a function or not a function? If I draw vertical lines, does any line cross at more than one place? No. So each line crosses in only one place. So this again would be a function. And what about our domain? So all diagonal lines are the same. And what do we know about the x values? Yep, positive infinity, because it's going to the left and it's going to the right. Yep, and same thing for the range as well, because the range is the y part, and that's going up and going down. Because range is up and down, domain is left and right. So this is going up and to the left, down to the right. So we have it there. And all lines, all diagonal lines are the same. Let's look at something that is not a function. And then we'll talk quickly about ordered pairs. So we're going to look at something that is not a function. Positive 1, and let's go 1, 2, 3, 4, 5. Okay, and then we'll go up 3 and down 3. Okay, so I'm going to give you something that is clearly not a function, and then we're also going to find our domain and our range here. And that's going to be 5. That'll be 0, and this will be and negative 3 here. So is this a function, yes or no? No. Why not? It's not a function because it's a circle, okay, and it fails the vertical line test. Because look at this. If I draw a line, what happens to this line? Okay, this line touches the graph at more than one place, right? So in that case, is this one a function? No, because it fails the vertical line test. Now, what about the domain? Domain is values of x, not the y, the x. Yep, 0 to 5. Very good work there. 0 to 5 on the domain. And what about the range? Yep, looks like it's going to be negative 3 to positive 3, right? Because we look at the y-axis and it's here to here. So that's going to be a negative 3 to positive 3. So that's your range. Now let's look at ordered pairs. And we're going to talk about ordered pairs. And we're going to do the same procedure. We're going to find the domain and the range of these ordered pairs. And then we're also going to tell if they're a function or not. And for ordered pairs, we look at the values of the x. So if all the x values are different. It is a function. So if all the x values are going to be different, it's going to be a function. Now the domain and range are the same. Domain is the values of x. Range is the values of y. So I'm going to give you some ordered pairs, and we're going to see if these are functions, yes or no. And then we'll also find the domain and the range. And what I like to do is I like to make a mapping. These are separate ordered pairs. Okay, so we're looking at each one of these. These are different ordered pairs. Okay, and we're going to see if they're a function or not. And so what I like to do is a mapping. So I like to see how they map out. And this is going to be the x, and this is going to be the y. So we have -3. It maps to 4. Okay? And then we've got 4. It maps to 8. We've got 9. It maps to 8. And then we've got 7. And it maps to 3. So, is this a function? I think it would be. What makes it a function? It says here in our definition, if all the x values are different, then it is a function. So every x value is different, right? We don't worry about the y's, only the x's. So that makes this then a function. So this is a function. Now, what about the domain? Domain is going to be the values of x. We're only going to list the duplicated values one time. And we're going to start with the smallest value. So what's our smallest value here? -3, 4, right? Put them in the correct order, 7, and then what? 9. Those are my values of my x. That's my domain. And what about the range, the values of y? Well, the values of y are going to be what? Are going to be starting here, smallest value 3, 4, and then we only write the the y of 8 one time. So we only write that 8 one time. So that is your range. So pretty simple in this section. It's not complicated at all. Let's do another one just to make sure we know the difference between a function and something that is not a function. So how about -3, 9, -4, 7, -3, 4, and 8, 1. Now the last one was a function. And what made it a function? All the values of x were different. Okay, because that's your definition of a function. What about this one? Well, let's make our mapping again. And then -3, what does -3 map to? 9. -4 maps to 7. But we have another -3, and it maps to 4, and 8 maps to 1. Now this one is not a function. And why is it not a function? It is not a function because we have duplicate x values. So that makes that not a function. And what would my domain be? And we write them from smallest to largest, and duplicated values are only written one time. So the smallest value is a -3, and then we've got 4, and then we've got 8. And what about our range? Well, that's the y values. Always start with the smallest, so the range is 1. And then we've got 4, 7, and 9. Now what we're going to look at next is we're going to look at equations. So we've seen pictures, we've seen graphs, we talked about the functions and the domain and the range. We talked about ordered pairs, we talked about the domain and the range, and if they are functions. Now we're going to look at equations, and they're a little bit more difficult, but not much. So this is going to be 4 equations. If you can solve the equation for y, it is a function. So if you can solve the equation for y, it is a function. These are going to be not functions. Any powers on the y. Those are not functions. So it's very easy to do. All you basically look at is ask yourself, can I solve it for y? And if you can solve it for y, if you can get the y by itself, it's a function. Now, all we really need to look at and make sure is that we don't have any powers on the y. If you've got y squared or y cubed or anything like that, then it is not a function. Okay, so we look at the y, and that's going to tell us if it's a function or not. We'll do some where we just determine if it's a function, and then we'll talk about the domain. The range is left for college algebra. We talk more about this in college algebra. But the range is more complicated usually to do, and so that's going to be left for college algebra. But the domain we'll look at today. But let me just give you some, and we're going to see if these are functions or not. Is this going to be a function, yes or no? Yeah. Why is it a function? Can I solve it for y? Sure can. If you're able to solve it for y, it is a function. Not y squared, not y cubed, anything like that. So that one was a function. Let's look at another one. And sometimes it might already be solved for you. Would this one be a function? Yep. Why would this one be a function? Because it's already been solved for y. What about this one? xy equals 12. Would that be a function? I think it would be. Because can I solve it for y? I think I can. Because how would you solve it for y? Well, you need to get the y by itself, right? And so how do we get rid of the x that's in front of the y? How does the x go with the y? Multiplication, right? What undoes our multiplication? Division. So we can divide both sides by x, and that gives me y equals 12 over x. So we were able to solve for y. So this is a function, isn't it? Okay. Now, what about this one? Would this one be a function, yes or no? No, it is not going to be a function. Why not? Because you have a square on that y. So because of that square, that makes it not a function. Same thing with this one. Is this one a function? Clearly not. Why not? Because of the 8. For that power of any powers in the y. If you have a power in the y, then that makes it not a function. So it's not a function. Now, once we have seen how to decide if it's a function or not, now we're going to talk about the domain. And we only look at things that are functions. I only gave you ones that are functions. In college algebra, you'll be looking at ones that are not functions, and they're a little bit more complicated. But for this class, all we really focus on is functions. So the domain is negative to positive infinity unless x is under a root or in the denominator of a fraction. So the domain is going to be, and this is usually what it will be, 90% of the time your domain will be negative to positive infinity. Okay? Unless your x is either under a root or in the denominator of a fraction. Those are the only two exceptions. So most of the time it's very easy to do. So here's one. Y equals 5x cubed. This is clearly a function. And what would the domain be? Do we have any square roots? No. Is x in the denominator of a fraction? No. That means my domain would be negative to positive infinity. What about this one? What about y plus 7x equals 14? You don't have to calculate anything out. All you have to do is answer these two questions. Are there any square roots? Not squares, just square roots. No. Is x in the denominator of a fraction? No. So what would my domain be? Negative to positive infinity. Let's look at another one. Now this one has a fraction, but is x down below? Is there an x in the denominator of this fraction? No. So no fractions, no square roots, so this one would again be domain of negative to positive infinity. Now where it changes, all right, where it changes is when you have a square root. Because of the square root, the domain is not, very important here, not negative to positive infinity. What we look at is we take what's underneath this square root right here, and we make sure that stays positive. So then if it's a square root, what we do is we set what's under this root to be greater than or equal to 0. Now, let's take a moment to talk about why we make sure it's greater than or equal to 0. Can I take the square root of a negative number? Can I take the square root of minus 5? No. Right? Minus 5, if you try to take the square root of it, is not a real number. In college algebra, you'll learn that it's imaginary. In this course, we don't even talk about imaginary numbers. So we look at what's underneath the root, and we need to make sure it stays positive. Because if it's negative, it doesn't exist. It's not a real number anymore. So if you have a square root, then what you do is you set what's underneath this root to be greater than or equal to 0. And what's underneath our root here? X plus 4. And now we can solve it. So we've got, moving that over, x is greater than or equal to a negative 4. And we want to write it in interval notation. So on a number line, here's our negative 4. It points, right? It points to the right, so that's where we shade. So we'll be shading in this direction. And what would the domain now be? Okay, we write our domain in interval notation. Our domain would be negative 4, and where does it go to? Positive infinity. So for square roots, what you do is you take what is underneath that square root and you set it greater than or equal to 0. Let's do another one, and then we'll talk about fractions, and that'll be it for today. So let's do another one. Here's another square root. How about y equals the square root of minus 3x plus 2? So we already know that this is not a function, right? So this is clearly not a function. Sorry, it is a function. The domain is not negative to positive infinity. If I say it correctly. Okay, because of that square root, the domain is not negative to positive infinity. It's something else. So what do we need to do? We need to set what's under this root greater than or equal to 0. Now, I picked this one because when we work with inequalities, what happens when we divide by a negative? It's going to flip my inequality symbol, right? So what is underneath my square root here? So let's examine that. What's underneath my square root is a minus 3x plus 2 greater than or equal to 0. We'll move that 2 over. So now we've got a minus 3x is greater than or equal to a negative 2. And I picked this one on purpose because when we divide by a negative in an inequality, what happens to my symbol here? Well, the symbol's going to flip. Negative and negative makes it a positive 2/3. So here's my number line. Here's my positive 2/3. It is pointing to the left, so I shade it back to the left. And then what is my domain now? Right straight from the number line. My domain is negative. Oh, wait. Sorry. Well, let's make sure. Yep, everything's right here. Yep, we graphed it. It pointed to the left, so we shaded to the left, which we did. And so it's going to be negative infinity to positive 3/2 with the square bracket. And that is my domain. Now, why is it going to negative infinity? Because when I divided by a negative, what did it do? It reversed or it flipped that inequality. Next, we're going to talk about fractions. And these will not take long at all to do. And I'll go ahead and pass out the sign-in sheet. And again, all we're wanting to do here is find the domain. So this one's going to have a fraction in it. We'll do probably 2, maybe 3 of these if we need to. So let's go ahead now and find our domain. And this one's going to have a fraction. It has an x below. Now, why is this one not negative to positive infinity? Because the x is in the denominator of a fraction. So because x is in the denominator, it is not negative to positive infinity. It's something else. Very simple. What we do is we take what's in our denominator and we set that denominator to 0. So set that denominator to 0. What's in my denominator? X minus 9. So if it's a fraction like this one, we set that denominator to 0, and then we solve it. So move that 9 over. So add that 9. And so now we've got x equals 9. Now, how do we write our answer? This is how we write our answer. And I'll talk about why we write our answer this way in just a moment. We write it as negative infinity to 9, union 9 to infinity. And this is the domain. Now, why did I write it like this? And why are we setting that denominator to 0? Well, can I take the square root of a negative number? We talked about that before. We can't take the square root of a negative number, right? It's imaginary. We'll learn about that in college algebra. It doesn't exist in the real world. Can I divide a number by 0? Can I take 4 and divide it by 0? No. Why not? Because that would be undefined. Remember when we did our slopes? If you have a number on the top and you divide it by 0, well, that makes it undefined. Okay? We cannot have something that is undefined. What happens if I plug the 9 in here? We found our number to be 9. If I plug my 9 here, 9 minus 9, that is what? 0 down below. And I can't do that. Now, why do I write it like this? Well, I write it like this because this is basically saying, in interval notation, all numbers work except for 9. Because 9 would give you division by 0. So that's why we write it like this. It's taking out the number 9. Every other number works but 9. Let's do 2 more. And then that'll be it for today. So let's do 2 more of these. How about y equals 5 over 3x plus 4? What do we need to do? It's not negative to positive infinity for my domain, right? Because the fraction, x is down below. And we set that denominator to 0. So that gives me 3x plus 4 equals 0. All right? Move that 4 over with subtraction. So 3x equals negative 4. So x equals minus 4/3. And how do we write our domain, our answer here? Our domain would be negative infinity to minus 4/3, u for union, negative 4/3 to positive infinity. Because 4/3, that negative 4/3, that would give you division by 0, and that cannot happen. I want us to look at one more quickly. This is going to be our last problem here. And again, we're trying to find the domain. These are all functions, by the way. About xy equals 12. Well, this is a function. Okay? And can I solve this for y? Yes, I can. So let's go ahead and solve this for y by dividing by our x. So that leaves you then with 12 over x. Now notice the x is down below in the denominator. So what do we need to do to find our domain? We set the denominator to 0. And what's in our denominator? Everything in my denominator is x, right? So that's it. And what would your domain now be? Domain would be negative infinity to 0, union 0 to infinity. Now we have done quite a bit today, but I think you'll find these sections to be really quick and easy. So what have we covered today? What's in your homework? Well, your homework is going to be 2.4, you should be able to do them all. 2.5, you should also be able to do them all. Our next exam is going to be next Thursday. So Tuesday, we'll do 2.5, which is the last section of this chapter. And our exam will be on Thursday. So try to keep up with the homework. I know, especially out of 2-3, it takes time, but all these